Have you ever wondered what differentiates scalars and vectors? Well, you're about to find out. Welcome to our exploration of scalars and vectors, two fundamental concepts in the world of physics. Imagine standing in a field and you want to describe your position. If you only provide the distance from a reference point, you've given a scalar quantity. It has magnitude, but lacks direction. However, if you say you're 20 meters north of the reference point, you've given a vector quantity. Vectors have both magnitude and direction, making them more complex, but also more informative. To denote direction, we can use various methods. Cardinal directions like north, south, east, and west, angles in degrees or radians, and positive or negative signs can all express direction. These methods are not mutually exclusive and often used in combination. Now, what happens when we try to combine vectors? There are two main methods, the polygon and the parallelogram. The polygon method involves drawing the vectors head to tail in any order, while the parallelogram method involves drawing the vectors from the same starting point. The resultant vector can be found by drawing a line from the starting point to the end point. When it comes to solving vector problems, we can use either graphical or analytical methods. Graphical methods involve drawing and measuring, offering a visual understanding of the problem. Analytical methods, on the other hand, involve calculations and provide more precise results. A common application of vectors is solving force problems. To find the resultant force, we need to consider the displacement, magnitude, and angle of each force. This might sound complicated, but with practice, it becomes second nature. And what about vectors in 3 dimensions? Well, we express these vectors in component form and calculate their magnitude using the Pythagorean theorem. It's a bit more complex than dealing with 2-dimensional vectors, but it's a crucial skill for anyone studying physics. So, to sum up, understanding scalars and vectors is essential for mastering physics. Scalars provide magnitude, while vectors offer both magnitude and direction. We can denote direction using cardinal directions, angles, and signs, and combine vectors using the polygon or parallelogram methods. Graphical and analytical methods help us solve vector problems, and we can express and find the magnitude of 3D vectors using component form and the Pythagorean theorem. Thank you for joining us on this journey through kinematics. Here's to a future filled with understanding the world around us, one vector at a time.